So hello, everyone. My name is Matt Dixon. I'm an agricultural meteorologist with the UK Ag Weather Center. If you're not familiar with us, we primarily work in extension, and our goal is to minimize weather and climate-related surprise for Kentucky farmers and producers. We do this in a number of ways by providing tools, models, and climate info for production and management-related decisions. All this info can be found at our website at weather.uky.edu. And going with our goal, today I've been asked to discuss how our weather conditions and climate has shifted over the past decade and what impact that could have on your grazing or livestock operations in general moving forward. I made some similar presentations earlier in 2021 for winter wheat and an irrigation workshop, but I've added some new info to make this more relevant to grazing operations in Kentucky. Overall, I'm going to discuss the difference between weather and climate, how our climate has shifted on an annual and seasonal basis over the past decade, and the impacts we've already seen across our Kentucky pastures and what we plan for in the future. Saying that, I want you all to think about how these long-term changes might affect your own operation moving forward. We all typically think about the weather right in front of us. What is it doing right now? Or what is the weather going to do over the upcoming week? I get it. That is the here and the now, and we all have a little weather nerd in us. So saying that, we have to be climate nerds too in our management operations. So starting out, what is the difference between weather and climate? I define weather as a short-term state of the atmosphere at any point in time. This is your 6 p.m. newscast from your favorite local meteorologist. He's going to tell you the current conditions and what the forecast is going to be like the next week. It helps you to plan your weekly schedule. It takes into account all the quantitative variables like temperature, precip, wind speed, etc. In ag, weather is what tells us when we are able to cut hay, run irrigation, spray, or even determines when we are able or unable to graze our pastures. The 2019 drought comes right to mind. Anyways, I want to pull your attention to the top right of the slide top of the slide and the quotation, weather is what you get, climate is what you expect. Keep that in mind as we move into the next slide. Our climate is the average weather conditions averaged over a specific time period. Usually this consists of a 30-year time span. So while weather focuses on the short term, climate focuses on the long term. Climate tells us what to expect at any point in the year. Our climate can tell us a variety of things that can have an impact on our management strategies. Our climate tells us when we can plant crops in Kentucky, what crops I can plant, what forage species I can plant and expect to thrive, the long-term sustainability of your own operation. And as I have said on the slide, maybe you're a row crop guy too, in determining whether you need irrigation or not. Below is a look at some climate info for the city of Lexington on a monthly basis. It shows us the average monthly temperatures and precip accumulations based on 30 years worth of data. These are called normals. Climate normals help us put our current and forecast weather conditions into perspective. Putting the weather and climate side together, let's say the high on October 26th in Lexington is forecast to be 57 degrees. Looking at our climate info for the city of Lexington, our normal high on this day is 65 degrees. So in the end, we are running 8 degrees cooler than normal on the day. In another example, climate normals also tell us that the state of Kentucky averages 50.38 inches every year, or the average first freeze in fall for the city of Bowling Green is October 31st. It's not to say we will see a freeze on October 31st, but rather that is when we would normally see our first freeze over the past 30 years. Again, this is climate is what you expect. But these normals can change. In fact, these normals are updated every 10 years to show any changes to our climate in Kentucky and across the United States. For the past 10 years, our climate normals had been based on a 30-year period of 1981 through 2010. But in 2021, those normals were shifted to the 30-year period of 1991 to 2020. We took off the years of 1981 through 1990 and replaced them with 2011 through 2020. This change gave us an idea of how our climate has shifted over the past decade and how our management strategies might adjust based on these changes. On this slide, I included a look at the shifts in our climate over the past century with each update to these climate normals and how it compared to the 20th century average. Looking at the maps, these are some normals where this is a look at some normals where we were warmer than the 20th century average and others where we are cooler. But the latest set of normals shows us running much warmer in Kentucky. We'll see how much warmer in the upcoming slides. Also, looking at precip, we're running much wetter than the 20th century average based on the latest set of normals. But this hasn't always been the case in Kentucky. Going back into the mid 1900s, we were running drier than the 20th century average. Bottom line, our climate is always shifting, and it's important to keep track of these changes as they could have a major impact on your management and production strategies. Ultimately, we've shifted to a much wetter and warmer climate over the past decade. So looking at the graph, I looked at 30-year normals on the previous slide, but now I want to shift gears to looking at data on an annual basis and how temperature and precip have trended over the past decade. Looking first at temperatures, this is a look at the average annual state temperature going back to 1895. I added a trend line to show you how temperatures have shifted over this period. We've seen ups and downs over the record. We saw a slight dip in the early 1900s before we saw warmer temperatures in the 1930s, which we commonly associate with those major drought years. We then ran relatively cool during the latter half of the 1950s into the 60s and early 70s before going on the uphill climb ever since. I want to point out something that Dr. Chad Lee said in the Winter Wheat Conference earlier this year. Notice that our peak in the trend line now is higher than the peak in the 1930s, which we used to associate with our warmest temperatures on record. That's not the case anymore. How warm has it been the past decade? So looking at this chart, the top 10 warmest years on record for the state of Kentucky, we've seen 4 of those years occur over the past decade. This data goes back to 1895. So on what is now over 125 years worth of record, we've seen 4 of our warmest years on record since 2012. I highlighted these 4 years in orange with 2012 coming in at number 2. 2016, 17 back-to-back at 4 and 5. Then you have 2019 tied for the 8th warmest year on record for the Bluegrass State. 2020 doesn't sit too far behind at number 17 on record. What also sticks out to me is that normally we associate these warm years with drought years. Hence, you see 2012 and 2007 on here. But recently, we've had some top 10 warmest years on record coupled with some of the wettest years on record. Now, does this mean every year from now on is going to run warm? No, but it shows that generally we've been heating up across Kentucky over the past decade. This has been the case across much of the United States. This map from the Cooperative Institute for Satellite Earth System Studies shows us the annual mean temperature changes between our latest set of normals in 1991 to 2020 minus the normals in 1981 to 2010, which were just replaced. All in all, most of Kentucky, along with the United States, is running about a ½ degree warmer. That doesn't sound like a lot, I realize that. But as I'll talk later in the presentation, it can have a big impact. Precip has also seen quite the jump in the trend line over the past decade here in Kentucky. The trend line doesn't have much variation throughout the past century until you get to the past decade and you really see that uphill climb. How wet has it been over the past decade? Well, I said earlier we had seen 4 of our top 10 warmest years over the past decade. We have also seen 5 of our top 10 wettest. Once again, this is not a small record with this data going back to 1895. 2011 tops the list when the state averaged 64.35 inches that year. 2018 was just behind at 63.74. 2019 sits at number 5, and then 2015 and our latest year in 2020 sit at number 7, 8 respectively. Comparing to the latest state average in the 1991 to 2020 climate normals of 50.38 inches, These years have run anywhere from 7 to almost 14 inches above normal. Despite having some short-lived periods of dry conditions through the 2021 growing season, it's also been a relatively wet year. Data is official through September, and over the 9-month period, the state has already averaged almost 43 inches, which is over 4 inches above normal and would be good for the 17th wettest January to September period on record. Looking across the United States in our annual precip change between the two sets of normals, Kentucky is seeing some of the highest increases across the nation. We are seeing our annual average increase by almost 10% for some sections of Eastern Kentucky. This wetter trend has been the case for much of the eastern half of the United States, while the western half is going in the other direction and getting drier. In this next image, the map was converted to the change in inches, and by and large, Kentucky is seeing the highest increases across the nation, more specifically Eastern Kentucky, 2 to 4+ inches across this region. The increase hasn't been as significant across Western Kentucky, but still in that 1 to 2 inch range. So what do the numbers look like when we look at various cities across the area? On this chart, I have included several airports across the region and the difference in average annual temperature and precip accumulations among the two sets of normals, 1981 to 2010 on the left and 1991 to 2020 on the right. Looking first at temperatures, most of these locations are running about a half to 1 degree warmer than what was seen in the 1981 to 2010 timeframe. Precip has been much more significant. Several locations, including Lexington, Louisville, and Jackson, are averaging 3+ inches more precip on an annual basis. Lexington even saw their annual precip average increase by over 4.5 inches in the latest set of normals. So just to end, we've been running warmer and wetter over the past decade across the state. So how about a seasonal basis? We talked about the annual basis, but does this warmer and wetter pattern translate across all the seasons? The answer is yes. In the next several slides, I made a time series scatter plot for each season throughout the year. I base this on meteorological seasons, meaning, which is a fun fact, is derived from the 3 warmest and coldest months of the year. On this slide, we start out with the winter season of December through February. Looking at this scatter plot, I plotted each year on the graph based on the average state temperature and precip average for the year in question. Just as an example, the average temperature over the 2018 to 2019 winter season was just over 39 inches. At the same time, the average state precip that season was over 19 inches. So if I trace a line from the 19 inches over on the y-axis and a line from 39 degrees on the x-axis, the lines will intersect up there in the right-hand corner. I then divided the scatter plot into 4 boxes based on the new 1991 to 2020 seasonal normals, the normal precip average in blue, and normal temperature average in red. In doing so, any years that show up in the upper right-hand box is years that saw above normal precip and temperatures. Upper left-hand box would be years with below normal temperatures and above normal precip. Lower left, both below normal precip and temperatures, and lower right would be years with below normal precip and above normal temperatures. I then highlighted the last 5 winter seasons in red. What do you see? They all more or less show up in the upper right-hand box. So in recent history, our winters have trended warmer and wetter across the Ohio Valley. How will this impact your operation? I've seen this picture way too much over the past several years. This was taken in February of 2019 by Dr. Josh Jackson, a UK livestock systems extension specialist and cattle producer in Mercer County. Warmer winters have led to a lot of mud, plain and simple. Warmer temperatures doesn't let the ground freeze, and most of our precip has been falling in the form of rain, which isn't the best combo for our cattle or producers themselves. Of course, these type of conditions will lead to more energy requirements, which means they want more to eat and can lead to hay supply shortages if it gets bad enough. I believe this was the problem across much of the state in 2019. You also have the case that mud can lead to health problems and decreased gains. Producers may consider concrete pads or other all-weather surfaces to mitigate some of this mud-related stress. A number of folks in the Department of Biosystems and Ag Engineering developed an extension publication talking about these surfaces ranging from concrete, geotextile, and rock to soil cement. More specifically, this can be found in Extension Pub AEN 115, appropriate all-weather surfaces for livestock. This is just one of many management options, including adding hay ring feeders or simply lowering the density of cattle over one particular location. Steve Higgins and Sarah Whiteman of UK Biosystems and Ag Engineering, along with Dr. Jeff Limkuhler of Animal Science, also discussed in the Extension Pub below, ID 188, about strategic winter feeding of cattle using rotational grazing structures. Going into the spring season, you notice the last 5 years are running closer to the climate averages in the red and blue lines. 3 of the 5 saw above normal temperatures. 2017 sticks out to the right there, along with the years of 2007 and 2012. What was common about all these years? Crop freeze damage due to warmer temperatures and more advanced development earlier in the year. This has been a trend as of late, but lucky for us, some years we avoid any late damaging freezes. This is a look at growing degree day accumulations from January 1st through the end of May since 2011. If you're not familiar with growing degrees days, it's basically a relation between temperature and crop development based on a base temperature for growth. Simply put, when we see the line increase, we expect a period of warmer temperatures in relation to the base temperature for growth and thus ensuing development of the crop in question. I honestly can't take much from this grass as it currently sits, but then I took the same graph and changed the colors. I highlighted 2016 through 2021 in red and 2011 through 2015 in blue. What do you see? The latter 5 years are showing much higher growing degree day accumulations earlier in the year compared to that of the previous 5 years. Thus, our crops are progressing into more advanced stages earlier in the year due to the warmer weather and thus becoming more susceptible to spring freezes. More information on this subject as it relates to alfalfa can be found in Extension Pub AGR 236, Managing Frost Damaged Alfalfa Stands. Looking at the summer season, 4 of the past 5 years have seen above normal temps, the only exception coming with a slightly cooler summer in 2017. All 5 have ran above normal in precip. That can have positives and negatives. One positive may be all the producers telling me how green the grass has stayed later in the summer months. Once again, this is a picture taken from Mercer County on July 17th of 2021 by Dr. Josh Jackson. While grazing may be perfect, our available baling days have taken a hit, something I'll talk about in a bit. Lastly, here's a look at the fall season. Going with the common theme throughout the other seasons, most of the past 5 years show up in that upper right-hand box, showing years with above normal precip and temperatures. Notice that 2019 even sits in that upper right-hand box, despite even having the driest September the state has ever experienced. Believe we only averaged 0.02 of an inch that month. 2016 sits by its lonesome in the lower right-hand corner with above normal temps and below average precip. That was the year we were dealing with wildfires across eastern Kentucky and down into eastern Tennessee. That brings me to my next point. I've been talking about how we've been trending wetter and warmer, but doesn't mean we can't have a dry month here and there. There are some images, these are some images taken from across the state in 2019 when grazing and hay supplies took a huge hit. Brandon Sears, an A&R agent in Madison County, shared with me his picture of burnt up pastures. Morgan Hayes, another UK Extension Livestock Systems specialist, showed me her farm and the other 2 pictures with livestock ponds drying up and pastures looking like something you'd see in the desert Southwest. That year was a double-edged sword, with grazing taking a hit, feeding hay very early in the fall season, and also not being able to replenish any of those hay supplies with fall cuttings. By and large, we still have to prepare for drought in Kentucky, but with the wet pattern in place, we've seen more in the way of what we call flash droughts, or droughts that can develop very quickly over the course of several weeks. On this slide, I included a drought time series for the state of Kentucky from the U.S. Drought Monitor. This gives us a look at the percentage of Kentucky encompassed by a certain drought category on the U.S. Drought Monitor over the past decade. You can see the color of the categories and how they relate to the impacts in the table below. Looking specifically at pastures, we consider conditions abnormally dry if they are showing mild stress. As conditions degrade, the State Drought Committee will recommend to the National Drought Monitor author to upgrade to the next category. D2 is when hay yields start getting low and supplemental hay might be fed. We saw this in September of 2019. Fall of 2016 saw a portion of the state go into D3, extreme drought, when some producers may consider selling livestock. Then lastly, you have the exceptional drought category, which hasn't been seen since 2012. Producers may start hauling water for livestock. Anyways, as you can see, 2012 was our last major and prolonged drought across Kentucky. The rest have been relatively short-lived with the wetter climate in place. In fact, since 2020, if we got dry, we only made it to the abnormally dry category for the most part and stayed under 20% of the state. All in all, we haven't seen anything that resembles the 2012 or 2010 droughts recently. Drought can still happen, but lately they've been less prolonged than what we've seen in the previous decade. Next up, the warm temperatures have greatly expanded our growing season here in Kentucky. In the top table, I compared the average first freeze date among 6 locations across the state and how they have changed among 3 different sets of normals. The average first freeze, according to the climate normals in 1977 to 2000, occurred sometime in mid to late October. Looking at the latest set of normals between 1991 to 2020, that date has shifted back into late October or even early November. In some cases, the average first freeze is occurring over a week later in the year. This was the case for Bowling Green, which has seen its average date move from average first freeze date move from October 23rd to October 31st. The second table shows the average last freeze date in the spring season. As opposed to the fall, these dates in the spring are getting earlier in the year with the warmer climate in place. Some locations are over a week earlier in the year when comparing the 1991 to 2020 normals to the 1971 to 2000 normals. This was the case for Louisville, which has moved from April 8th to March 31st. Looking at the last table, I took a look at the average freeze-free period based on the dates above. With our last spring freeze occurring earlier in the year and our first fall freeze typically occurring later in the year, our growing season is showing some significant expansion. Good news for grazing across the state with more expected forage growth earlier and later in the year. Once again, Bowling Green saw some of the more significant increases going from 195 to 209 days. Louisville increased from 205 to 221. Lastly, I wanted to take a look at baling days with the wetter climate in place. In this table, I compared the number of baling days for a few cities across the state since the year 2000. I broke it down into monthly and annual formats, taking the average of the years 2000 through 2021 and comparing against the average of the past 5 wet years in 2017 to 2021. And making this chart, I strictly only took into account whether or not a location records 0.00 inches for at least 4 straight days. I did not take into account relative humidity, wind, solar radiation, or any other factors, simply whether or not there was precip. I also didn't account for any light accumulations that may not have had much of an impact, strictly 0.00 inches or bust. I understand that you can get hay baled in a 3-day window during the summer, but for the sake of simplicity, I stuck to a 4-day window throughout the year. The 4th day was considered a baling day and any other consecutive dry day thereafter. Just as an example, if we had a 7-day period of dry conditions, days 4, 5, 6, and 7 would all count as baling days. Looking at the annual numbers first, Lexington averaged nearly 39 baling days a year based on the 2000 to 2021 average. That average drops to 35.4 days when only taking into account the past 5 years. In total, we've lost 3.5 baling days on average over the past 5 years. Bowling Green and Paducah, while seeing more overall baling days, they also saw decreases over the past 5 years. Look at the monthly stats. Unfortunately, the highest decreases are coming in the months of May and June, as we've lost 1 to 2 baling days the past 5 years. That doesn't sound like a lot, but looking at the averages, that's pretty significant. Looking at May in Paducah, They only averaged 5.8 baling days in May to begin with, based on the 2000 to 2021 average. Looking specifically at the month of May, I made a chart showing the number of baling days on an annual basis for each city compared to the average among the stations during the month of May. Since 2016, we've stayed under that 6 baling day average for the most part. We did have some good drying weather in May this year, but 2020 was a much different story, with Bowling Green not even recording 1 baling day. The range in baling days over the past 6 years has ranged from 0 in Bowling Green to 20 in 2020 to 9 in 2021. We'd much rather see the rain than drought, but it does make for some headaches when we have tighter windows to get hay out of the field. Lastly, I want to close with a little info about emergency preparedness. As farmers and producers, we have to be prepared for any type of natural disaster. Flooding has taken center stage over the past several years with our wetter climate in place. Storms have shown capable of producing devastating amounts of rainfall. If you're not familiar, the Tennessee State 24-hour rainfall record was broken in late summer this year in Waverly, Tennessee. They saw more than 17 inches in less than 24 hours. Let me repeat that again, 17 inches in 24 hours. Damage was tremendous, with many losing their homes, hayfields left underwater, fences torn down, some even losing their lives. While this happened in Tennessee, Kentucky has had its own share of historic flooding this year. Bardstown got hit hard recently. Nicholas County was under a state of emergency in early August when they saw 3 to 4+ inches within a short time period. And of course, we can't forget the historic flooding in early March this year, following 3 straight winter weather events across the area. I had included a picture on the right showing a horse stuck up in a tree, something you don't see every day. But this was taken during the 1937 flood over in Louisville, when crest was 30 feet above flood stage. Louisville saw 15 inches of rain in 12 days during January that year. The horse got caught in the flooded water and then caught in a tree. Water then receded, making it easy, and saying these guys are about 6 feet tall, it would be about 18 feet to the hind legs of the horse and 24 feet to the head. While our infrastructure has greatly improved since then, we still have to think about emergency preparedness. Some questions to ponder. Do you have a way to receive warning? I inserted a picture there showing no weather radios. These things can save lives and animals and can be picked up for as little as $20 to $30. They'll wake you up in the middle of the night to alert you as to any severe weather. Make an emergency plan for both family and farm. What if you have electrical loss, limited access to clean water, roads are blocked, you have down fence or loose animals? Take everything into account. Make an emergency contact list and also keep an up-to-date list of on-farm inventory. Also, you may consider putting together a farm disaster kit and stockpile items. How about alternative power supplies, fence supplies, extra fuel, additional feed, dry bedding, and alternative sources of clean water? Bottom line, are you prepared if there is a disaster? So that's what I have. How will this warmer and wetter climate affect your operations? Something to brainstorm moving forward. This is just a touch of some of the impacts of a wetter and warmer climate ahead. But as I said in the proceedings, this list could be greatly expanded. And one example, warmer winters could lead to pests overwintering farther north and putting Kentucky more susceptible to northern migrations. But I'm going to leave that to the entomology experts. In the end, I do realize we are always concerned about that short-term weather forecast, but there are benefits to looking long-term and making sure we are successful in our management and production strategies. In monitoring the weather and climate, I've included a couple resources on the right, and they can also be found as a link in the proceedings. The first is the Ag Weather Update, which I started earlier in the growing season. This is a newsletter where I take a look at current conditions, the weekly forecasts, and long-range outlooks. I also will occasionally add a topic on our climate. The hope is I can take this to a video format for 2022, something I'm currently working on. The second resource is a monthly webinar hosted by the Kentucky Climate Center titled The Kentucky Monthly Perspective on Drought and Hydrologic Conditions. We'll go over the current climate conditions over the past month, outlooks, and any impacts being seen across Kentucky. These are held the first Thursday of every month at 2 p.m. Eastern, 1 p.m. Central. I posted a link to the sign up in the proceedings, but I'll also post it on my Twitter account, which you can find on the weather.uky.edu homepage when the date gets close. Our next webinar is scheduled for Thursday, November 4th. So that's what I have. I want to apologize that I wasn't able to be there today. I had some prior plans already put together, but please feel free to contact me with any questions or comments using the info on the slide. Thank you very much.